without further ado, we would like to move to our first session, in which Derek Hayden, Chris Sciullo, together with Tim Vlamis, will be talking about how at OUTFRONT Media they're using Oracle Spatial Studio and Oracle Analytics Cloud to find real estate development opportunities. Just a quick few words on the speakers. So main speaker is Derek Hayden. Derek is a senior VP of data strategy and analytics at OUTFRONT Media, and he has spent the last 7 years architecting a high-value analytics practice within OUTFRONT Media, which, by the way, has earned him an Oracle Analytics Visionary Award, as well as the title of Oracle's Data Warehouse and Big Data Leader of the Year for North America. And he is joined by Chris Sciullo. Chris is a senior analyst with OUTFRONT Media, and he's joined Derek's team only in August of last year. And among his first activities, he took Spatial Studio and OIC to contribute to the delivery of the first version of OUTFRONT's real estate playbook. And then finally, last but not least, the third speaker is Tim Vlamis. Tim is VP and Analytics Strategist at Vlamis Software Solutions. You may have come across Tim previously because he and also his brother Dan, who was moderating yesterday, have been very active contributors to the Analytics and Data Oracle user community for many years. He's an Oracle ACE director. He specializes in data visualization and machine learning, predictive analytics, and he does maps and geospatial analytics. And with that, I'd like to hand over to Derek and the team. So Derek, the floor is yours.
Thank you, Hans. Let me grab this. All right. Good morning, afternoon, evening, everyone. I'm told that this may be a little jittery, so I won't stay on it too long, but it's kind of our brand video and title slide on putting the L in TLC. It's a very important part of our branding. The L being location, technology, location, and creativity. So if you were here about love, I'm sorry, that is not what we're here to talk about today. Oh, shoot. I had placeholders in for till we got the headshots. Sorry. There we go. There we are. I think Hans gave a pretty good overview of who we are. Thanks for the shout out about the Oracle Awards. I actually forgot about those. Probably more, the karaoke singer is probably more important to me right now. So you're going to hear from all three of us today. I'm going to set the table and then let Tim and Chris kind of walk through how we got to where we are. So just a quick overview of OUTFRONT Media. We're one of the largest out-of-home companies in North America. Really our mission, well, actually we want to connect brands with customers, and we deliver our impressions through an asset portfolio. And our mission really is in TLC, and this is actually a mission on our from our website. So location actually is part of our mission statement. Without location, our asset portfolio can't be positioned to be delivering assets or delivering impressions for brands, and that's really what our job is for our advertising partners. Just a quick, really high level of what our portfolio of products are. Today, we're really going to play in the space of the purple. You'll see we have about 47,000 roadside assets versus about 465,000 bus and rail assets. So, but our revenues, 2/3 of our revenues come from those roadside assets. So it's really important that we make sure we have premium assets in place to deliver brand impressions. And one other just quick reason everything we do, we're really trying to set the table for driving allocation of media spend dollars into out-of-home. Out-of-home is one of the only fast-growing medias along with mobile internet, but you can see the mobile internet share is way bigger than ours. So, between technology, creative, and location, we're really trying to grow that bubble, that 7.3 bubble. That's really kind of everything we do is geared toward making that bubble bigger and convincing advertisers to utilize us. And we feel like we're a really good partner, and we do a really good job of delivering brand impressions. So brings us to what this use case is really about. So our real estate representatives, they're tasked with finding opportunities to either build new locations or upgrade existing locations to a premium asset. And that can be, digital is kind of our push with technology, but, just even finding locations to build new assets is kind of tough in this industry. There's a lot of regulations in place that prevent new assets from being stood up. So we kind of have to protect and be creative with our existing assets while going out and trying to build out our portfolio. So our reps were using a combination of tools, whether it be Google, they go online, they'd have manual spreadsheets of our inventory. We would see that they'd show us, they would take a picture and cross it up over a Google map, trying to figure out where locations were. So goal was to create a tool that let them look at the locations that we have in a tool that they could also bring in data from our data warehouse around rent and revenue and that type of thing. And our key assumption around this use case was that our lat and long information was highly accurate. And that based on that, we could enhance our data with geospatial attributes that really weren't well curated in our source systems. So lat and long was really important to us. So we looked to Spatial, we looked to ADW and OAC to kind of deliver this result. So we were feeling really, really confident when we started. We did a Code Innovate with David, who's speaking later, was on the Code Innovate. And we kind of vetted out all the technology and the concepts. And so we were last year feeling really, really, really confident that we could deliver something impactful relatively quickly. The reality is it started more like this. I just realized it's really hard to read the audience when you can't see them. So hopefully this is making an impact. And so, we ran into a lot of problems, and that's where I'm going to hand off to Tim and Chris to kind of walk us through the solution. So Tim, I'm queuing you up for getting on camera and on.
Yeah.
All right.
I'm here.
So here you are.
All right. So thanks, Derek, and I'm happy to kind of review some of the hurdles we ran into, and in the beginning, what we thought we were going to be working with were administrative boundaries in the United States, and so the challenge is basically this is organized by what's been established, and the traditional hierarchy is kind of state, county, sub-county. Well, the reality is cities were incredibly important to OUTFRONT Media. In particular, cities manage, the rules and regulations around, locations. And so, for example, I'm, speaking from Kansas City today. Kansas City spans 7 counties, and the overall area goes across 2 different states. And so, and the sub-counties are not administrative. They have no, purpose in terms of applying rules about real estate. It's all done on a municipality basis. So basically, what you have is you want to know, is this particular location within an incorporated area or an unincorporated area? And so this, we did not have access to good boundaries for the United States for incorporated versus unincorporated. So immediately what we found when we went to put this into production was, and this was kind of, so if you think about the basketball goal, it's a little bit that the goal got moved, right? Because we started and then we met with the real estate group, and they're like, no, it's all about this very specific locations and where they are. Are they in a city or are they in a county? You know, and so we kind of had to do a reset. And I'll show some examples of that. We also ran into the challenge of, these very, very large files at the very local level. So in other words, once you take all the sub-counties for the United States, if you have that layer, it became too big to put into OAC. So that was an issue of, how big these files are. And of course, everybody suggested, well, why don't you just smooth them and make the files smaller? Well, that's great, except that when you smooth these county borders or these sub-county borders or these city borders, what ends up happening is you actually misallocate certain locations. And most of OUTFRONT's assets are not at a specific address. They're along a highway or something like that. And so literally whether they're on this side of the line or the other side of the line becomes very, very important. And the smoothing function can move the lines, several hundred feet or several hundred meters. So it was a big challenge. So this is this smoothing can't be universal. This is not about geometry. This is about how we actually understand how these maps are drawn at a very, very fine resolution. And the third challenge, the main challenge, was we found that reverse geocoding is designed for addresses, not for locations. And what ended up happening was we went through the reverse geocoding process where we had a specific latitude, longitude, it would actually assign it perhaps in the wrong city or even the wrong county because it's looking for the nearest postal address, not for the actual physical location, and then doing some kind of spatial join to what the jurisdiction is. Next, yeah. So this kind of shows you the hierarchies for the US Census. This is the way most of the data is organized. It's either organized by driving or by, in other words, kind of navigation, or by this, kind of government hierarchy. And as you see, nations at the top, and then you get into regions, divisions, states. And then once we get into these counties, you'll notice it goes into, states goes into two different areas, school district, congressional district, and then they have these urban growth areas, et cetera, et cetera. Counties goes into sub-counties, census tracts, et cetera, but nowhere on this little, hierarchy, does the word city appear. This core-based statistical areas crosses over. It's literally at the nation level. So the closest thing we had to a city, an urban area or a core-based statistical area, was not appropriate for the purposes of the real estate analysis in terms of what are the rules that apply to this location. Can we convert this particular billboard from a physical billboard to a digital billboard, for example? For that, you have to know, the zoning and the regs. All right, next slide. This shows an example of one of the reverse geocoding areas, errors that we had. So we had a location here, and where we went through, we did a lot of work to get the reverse geocoding work. We had a lot of help from Oracle, but ultimately what happened was there were several errors that occurred, and I think it was around, several hundred. So it was in the hundreds of assets that were actually misassigned. So you can see that this was close, very close to a border. And when it's close to a border, this very, very specific lat long actually got placed in the wrong city or the wrong county or whatnot. And we found that even with other clients we're working with, where you know, that an address in you know, Detroit may be assigned to Detroit, even though it's actually in the unincorporated county that's near Detroit. It'll still have a Detroit street address. So that's kind of the problem we were having. Yep, next slide. This issue of, you know, taking these counties and, you know, trying to make the files smaller, just thought I would share this workaround we found, which was that a lot of the detail and the size of the files came from a relatively small number of counties. And in particular, coastlines had a huge impact on the size of the files. So for example, we're looking at a county here in Maine, which is the upper northeast corner of the United States. Not an area that had a lot of assets, but it shows kind of the problem. So Hancock County here on the far left, you can see that it's got you know, coast, and then as we zoom in the middle, you can see that there are several hundred islands, and all of these islands had vertices and that drew the outline very specifically. We needed this level of fine detail for the borders between counties on land, but once we got to the coast, it became very large. So what we wanted to do was to figure out a way to eliminate only the detail on the coast. And by doing so, we went from 41,000 vertices to a few hundred vertices. And next slide. So the process we used was to use Spatial Studio to develop a script that we could then run in the database in ADW. So we used the rubber band method to create the rough outline of the county. And then what we would do is actually remove the overlap with the border. So we would do any interact. You'll see we have the specific functions that we use, but we would then cut out, if you will, the overlap with the other counties, the bordering counties, because they did still have their detail. And what we did was then, so what you see up here in the upper right corner, you can see that we have the rubber banded county for Hancock, and then we cut out the surrounding counties. So what we were left with was a detailed border inland and a rubber band border on the outside. Now, there is some downside to this methodology. You know, the assignment of which island is in which county can be unclear. You can also lose the detail of inland islands with this method as well, so that you're not actually, you know, seeing that. So that it's possible that we could have some problems, but we found was we were able to drastically reduce the size of the county layer. Next slide. So this is just for the, you know, you guys that are interested in, you know, which particular geometry functions we used. We you use a rubber band, so that's the convex hull method to outline on a very, you know, simple border basis the target county. Then we used SDO interact to identify which counties bordered that particular county, and then we did a difference function to remove the overlap. So what we did is we actually set up a for next loop so that we could iterate across all the different counties. So otherwise you're left with doing it individually in Spatial Studio. So we use Spatial Studio to develop our methodologies, and then refined the actual scripts that we were able to execute on, the very large number of situations we had in the database. So it worked really, really well. And then there was a second loop to, because if you will, as you cut out that border, if you will, and you replace it with a detailed one, you can actually introduce more complexity. So you want to go back to one of the rubber band borders offshore where they overlap. So that was this loop number 2. And it is a bit arbitrary as to which county actually got the overlap area between them when it was offshore. So, but that's just, you have to make a call one way or the other. The last county processed got the extra islands. All right. And I think that is
we're gonna tee up Chris now to get us to the end line here. All right, Chris, you ready?
Sure. Yeah, as Tim alluded to, we had a few different challenges along the way, and this is kind of a demonstration of some of the things we did to work through the challenges, as well as kind of some ideas we have going forward with what we plan to do with the report. We had the same issues in terms of talking about with the inaccurate joins. We also had some sizing issues we had to deal with. As this was new data that we were unfamiliar with, we had to do a lot of cleaning to kind of get the data to work properly with spatial as well as OAC, and then we had to simplify the map layers as well too. So this first example is alluding to what Tim had mentioned earlier, is that there are different degrees of inaccuracy that we were experiencing with different vendors. This is kind of an example here of a lat long that was located in a different city, and we used Google Maps to verify these locations. Ultimately, we resolved this by using OpenStreetMaps, and we found that to be more accurate than the vendors that we've been working with previously, as well as we can leverage a lot of the geotagging capabilities within OpenStreetMaps for kind of any sort of additional calculation or any sort of research we want to do going forward. Go to the next slide. So to pull this data from OpenStreetMaps, I had initially written a PowerShell script, which is going to go through state by state and just kind of pull the various layers that we needed. So just to kind of explain a little bit, administrative layers are handled differently in different countries. And in the United States, the administrative level 6 is a county level, administrative 4 is a state level, and administrative level 8 is a city level. And so I was basically writing a PowerShell script that was going to loop through and pull everything. Ultimately, we decided on using a front end called Overpass Turbo that would allow us to kind of fine-tune our querying to kind of get the polygons that we wanted to for our maps. Kind of the one problem we had with this was that there's a limited number of information you can pull at a time. So this is an example of maybe pulling a little bit too much data, and the API threw an error that wouldn't allow us to pull it. And occasionally, when you would pull a large amount of data, the browser could occasionally crash as well too when trying to render it to the screen. So there's a few different challenges where we ultimately had to break up these map layers into different files. Next. As I mentioned earlier, this is all kind of new data. I'm familiar with what's kind of in the tagging. So there's a lot of special characters that were in the that were being used in fields. Some of the formatting was a little bit off. So it's a matter of going through and just kind of scrubbing the data. Not a fun process, but just something you have to do in order to try to make sure that everything is going to work properly within Spatial, so we can get the kind of joins that we need to get the kind of geodata that's going to work for us. Next. So I used a tool called MapShaper ultimately to convert these GeoJSON files to shape files. We had tried using GeoJSON files to perform the spatial joins we were trying to accomplish, it didn't quite work out. We found out it was just easier to kind of use shape files. Not to mention, this tool was able to merge all of the different layers that we had pulled into one giant shape file. So we can create one map layer for an entire county layer or city layer, state layer, what have you. Next. And lastly, this kind of touches to what Tim was saying, although there's kind of an update to this. We wanted to use the shape layers that we had built as map layers one-to-one, or I should say the shape layers that we use for spatial joins as a map layer in our reporting. There is a 20 megabyte cap on the size of the shape files, or I should say the GeoJSON files being pulled in, and these layers were considerably larger. So we had to simplify them, which means kind of changing some of the polygons, making them a little bit more blunt in order to get the reporting to kind of fit within map layers. That being said, it turns out that this is actually something that Oracle is addressing within the upcoming months, and they're actually going to be rolling out an update that's going to kind of change not just map layers themselves, but also kind of the ability to use geom fields within OAC. So we can actually kind of draw the polygons directly from the data as opposed to utilizing the map layers. Next.
Yep. So we did get there. This was all like a Debbie Downer bunch of slides, guys, but we did get there. You know, I think we ended up with a pretty good end product. I think, Chris, you're gonna, hopefully this will work. Let me know if it gets a little herky jerky, but if you want to walk through this.
Sure, absolutely. Yeah, so this is a very early stage of what we're working on, just trying to kind of accomplish. You can see we wanted to pick an area that had multiple states within it. Those blue polygons, can you pause it for a second, Derek? Perfect, okay. So the blue polygons are actually county layers, and the red polygons are actually city layers. And this is, again, all pulled directly from OpenStreetMap. When you highlight the polygon, you can see, or maybe see on the screen, that there's a county ID. That's a primary key that's built within OpenStreetMaps. Kind of the plan is going forward, we can use that primary key to kind of interact a little bit more with OpenStreetMap's API. Or if we want to pull like kind of a larger amount of data, we can use this to join to it and kind of pull more information. Just kind of, we want to have some type of anchor to not just our data, but also the polygons that we're using to populate the screen as well too. And can you play, please? Yeah, let's go. It's the same concept for city, so we'll be able to use that ID to directly connect into OpenStreetMap's data and pull it. And we wanted to be able to kind of turn the layers on and off and have some interactivity with that, so our users can, maybe they don't want to see the city layer, or maybe they want to see the county layer, or they can kind of go back and forth between the two as well. So we wanted to highlight some of the information on screen and also to the right of the different assets that we have available to us. And additionally, you can interact selecting multiple assets by holding down Control. We have this Spatial Selector that you can kind of determine the distance between points to kind of check to select a series of things. So this was just to get an idea of where things are. This next step is we've built a data action that will take us to an additional report that we have built. This has a little bit more nuanced information, more leasing information in case that's something somebody was looking for. And from there we have a data action that takes us to a completely different report that we have. This is, again, more nuanced leasing information, and that hyperlink is actually, will take you to a PDF of the scanned contract itself, the signed lease itself. So this kind of just an idea of how we can go from seeing a bunch of dots on the screen to actually seeing the contract that established that dot in the first place.
Right, and just for some additional context, that's really our real estate reps, you know, traditionally thought in the concept of a lease. You know, they were always they're always tasked with renewing leases. We didn't want to ever lose a site because they were always so hard to rebuild. So traditionally, and I've been here long enough so that I can actually say this, you know, everything was about the lease. Everything, you know, we've had to actually walk them back. And some of the directive that's come down from the top now is like, you really need to understand the location is really what you're after. And, you know, they've changed kind of incentives and measurements to be location based, like how many builds are you doing, how many conversions, you know, and what we did here is, you know, we added this geospatial element of data that, you know, people probably were doing manually if they needed to, but now they have access to it. And we've tied it to the information in our warehouse that was already there. So we've kind of like, you know, we've exposed both sides, the location and the lease in one tool very, you know, kind of really quickly. So they can go at the location and then their brain starts to think, well, who owns that? You know, what are the contract terms? Can I get out of that lease? That type of thing. You know, when does the lease end? Is this a good location? So that's what we're trying to tie together in OAC, is all these concepts. Oh, what did I do, Chris? I'm back to the same one. Oh, sorry. There we go.
Yeah, so we have some ideas of what we want to do going forward. Again, I had mentioned that we really want to hook into some external data sources to be able to leverage data outside of what we currently have. And so we have some ideas in terms of incorporating competitor data. As I mentioned before, there's going to be some ONC enhancements in terms of geoms being able to be used as a field, so we can draw the polygons directly to the map that's on screen. And we look to include different types of boundaries. I mean, for anybody who's ever worked with OpenStreetMaps, or maybe people who aren't familiar, it's an open source database. There's a tremendous amount of geodata in there that we can leverage going forward. And we hope to kind of use that to get some ideas of looking at data a little bit differently than we had previously.
Right, I'll just start this one quick thing on the last, you know, so one of the things that we can do, we can leverage these tools, you know, so for example, if we're looking for new opportunities, one of the things we don't want is for people to chase down things like in a residential area. So zoning becomes really important because we know there's certain zones we can't build in. So we want to help in future releases, you know, kind of really get them to key in on the areas of interest where they can really actually make an impact and not start chasing down incorrect, you know, oh, I'm going to build next to a house like that. We know that that's out of bounds. So that's why it's just important that we start layering in these, you know, additional detailed complexities. And Chris, you had one more here real quick before we go to questions.
Yeah, this is an example. This is a very early prototype of what we want to do with competitor data. So this is actually, can you pause it for a second? Right. So I had written a PowerShell script that was hooked into we use GeoPath as our client to kind of measure a lot of competitor data. And so I was able to kind of pull all of our competitors and kind of write them to a CSV file and fine tune it a little bit. It's a lot of data, obviously. And so we have this kind of block of data with all of our competitors combined with, or sitting side by side with our data. So we're able to kind of get an idea of what we're looking at in terms of who we're going against and kind of maybe where we're overmatched. You can hit play. Oh, and for this case, I had to remove the layers. We're still working through the data and trying to figure out how we want to use it. So there's still some decisions that need to be made. So there's no counties or city layers on this, but we'll intend to add that at some point. So this specific area I wanted to point out, we have one competitor that seems to be kind of, you can mouse over that and see that, one area that is kind of surrounded by us. And so we wanted to see what kind of competitor this is. And it's a digital panel. It's got a few different assets there. You can see the immediate our asset next to it. And so I wanted to be able to compare side by side what we're looking at. We have some bulletins that are not digital on the left, and we're going up against digital media on the right. This is maybe going to create some ideas of what we want to do with this specific location. Do we want to compete at a digital level or not? Do we want to maybe move away from there? So the idea is this is just going to open up our data and looking at it in a different way that we hadn't previously, maybe kind of inspire a little creativity of what we want to do going forward.
think we said we were trying to leave 5 minutes for questions. I think we nailed it.
I saw a couple, an example to share. I might need to get a little more information on that. But we can try and talk offline at some point to get a little bit more to go through that. Did you obtain traffic? We did not have any traffic volume information. In terms of traffic, I mean, I'm sure that that's something that would be available.
Yeah, so Chris, I can actually speak to that. So a couple of our vendors that we engage with to try and accelerate this process, it was really interesting because they were way more, once they kind of got a whiff of who we were, they were way more interested in selling us, traffic data and things about like who was going where. And we were really trying to solve a very different problem, right? That is definitely audience and who's going by our assets of interest for sure. And it's something that we're trying to solve. But this particular use case, we were really trying to solve something completely different around administrative boundaries. So it's funny, we do intend at some point to, like, these concepts will eventually marry up, where we might want to say, oh, we want to look at volume because we don't have something here. Does it make sense? Is there a volume of traffic going by here that we'd be interested in? But the vendors we were thinking of using were really just interested in selling us data that didn't even apply to this use case.
Hey, Derek, I think it's worth mentioning also that you guys are trying to, create some common practices around the different groups across the country that are managing different areas. And so, one of the objectives at the very beginning was to say, oh, let's just put in a common foundation so that everybody's using the same thing. So we don't have the team in Michigan doing something different than the team, in Pennsylvania and Philadelphia.
Right.
And as we try to find common sources of data and for shape files of different jurisdictions and this and that, we found that's where one of the challenges was just organizing and collecting, finding someone who could provide what we were looking for.
Right. Trying to look on here.
Yeah, there's another question.
Does safety enter in? No, we don't care.
Yeah. So actually, we did. Well, I mean, if you want to reach out to me, we've done some work with the Alaska Fish and Game folk. So if you want to talk about fishing.
No, definitely. I know I was joking a little bit about safety, but I mean, it's definitely part of any pitch that we do. We have to look at safety, and there's regulations around if you do digital, how bright something can be, how often it can flip, and that's all, again, from an administrative standpoint. Every jurisdiction has their own rules, which is really why we're trying to give people the ability to carve out these areas to create a playbook by every one of these districts. Just one last anecdote. We had one in Tampa, I think it was Tampa or Fort Lauderdale, where the regulation was you couldn't be within, the minimum distance between any other advertising structure was 1,500 feet. They actually went and lobbied and changed the regulation to make it 1,000. So we actually had a separate track, not here, but be of some interest at some point, where we actually carved out all the new space that got created by that regulation. We measured distance between all this, and we're trying to identify, hey, can we now go put something here? Again, all part of this playbook thing, and those are the types of things we have to address, because something like that in Tampa may not happen in LA. Something completely different in LA may come up, and that's why these tools are really important. But to Tim's point, having a baseline for everyone to start at is really key for us to start here. I think that's it on the questions.
Okay, so with that, then I think we can switch back. Thank you so much. Wayne, do you want to take over?
Thanks, guys. It was great.